Okay, let's give you guys some practice now. So in one of the earlier videos, we set up a model for the body temperature of a lizard, and we started out with our sine graph. We started out as a sine graph. We set up a model saying that the body temperature of the lizard deviates by 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 what is it 5 degrees, by 5 degrees either way. Okay, and then we started out with this graph here. Hang on. We started out with this sine of x here. We then changed the period. Remember, sine of x normally 360 here. 360, but then we changed it to 24, and then we changed the amplitude, and then we moved it up. We moved it up. Oops, hang on. And then we moved it up like this, and then we moved it across like this because we said that the sun rises at 5 in the morning here. The sun rises at 5 in the morning here, so that's when the temperature increases. And then here is night time here, and then the temperature starts to decrease, and then the cycle starts again. The sun rises at 5 in the morning, so normally, hang on, normally our sine of graph, our sine of x was like this. Hang on. Normally our sine of x was like this. We had to move it from the very bottom of the sine of x here. We had to move it across to 5 in the morning, just so that it would sink in with the rising of the sun. Okay, so the sun is at 5 in the morning. Well, anyway, now it's your turn to have a go. So now we are on a new planet now. So here our planet here. Well, 1 year is when it makes one orbit of the sun. But the thing is, 1 day is when it makes one turn here like this. Okay. Well, I can't remember if it turns this way or if it turns this way. But one year is when it orbits the sun once. But 1 day is when it orbits when it makes one rotation. So this planet, the new planet that we're on, 1 day is 40 hours. Okay, and we've got a new cold-blooded animal on that planet. So we're going to model it like this. So this animal here, so our animal here, remember 40 hours in 1 day on our new planet. Okay, 40 hours. So we start off with our sine of x here. We start off like this, and our animal here, the body temperature of this animal deviates by 7 degrees. So it could go up by 7 degrees Celsius, or it could go down by 7 degrees Celsius. But the thing is, it's its average, hang on, its average body temperature is, well, it deviates from the 100 degrees Celsius mark. So on Earth, water boils at 100 degrees Celsius here, but this animal survives at, well, we are just pretending that this animal exists. So your job is to model the body temperature of this animal. Okay, so it hovers around the 100 degrees Celsius. Okay, and then it deviates by 7 degrees Celsius above 7, and it will drop by 7 as well, but it hovers around the 100 degrees Celsius. Now the very bottom of the graph is right here, but we need to move that across to sync with the rising of the sun. So hang on. So let's move this across. So normally it's like this. Okay, we got to move it across so that at this precise point here, 3 o'clock in the morning, that's when the sun rises on this planet. So this planet here, the sun rises at 3 in the morning. Okay, so somehow model will come up with a formula for this for the body temperature of this animal here. So yeah, so normally, hang on, let me just clean this up. Normally hang on, bear with me. So here, this is our normal sine of x here. One period is 40 hours. Okay, you need to change. You need to well, you start off with your, hang on, you start off with your sine of x, which is 360, you need to squeeze it so it's 40, and then you need to stretch this because it deviates by 7, and then you need to move it up to so it hovers around the 100 degree mark, and then you need to move it across by well, somehow you've got to move this point here across to sync with the rising of the sun. Okay, so somehow you want to get it to be like this. Hang on, you move it up so it hovers around the 100 degree mark, and then you need to move it across so this bit here matches up with 3 o'clock in the morning. Okay, so somehow press pause and have a go. Okay, come up with the formula for the body temperature of this. Okay, so press pause and have a go. Okay, so to do this here, let's start off with our sine of x here. So this is our start. Well, make this up. I'm just going to use b for body temperature, but you could use f of x here. You could use body of x here, or you could say body of t, where t is time. This is actually a better name than this. T is better because t identifies that it's time. X could be anything, but it doesn't matter. For this one here, we're just going to use b of x. Okay, this means well, b here stands for body temperature. So anyway, start off with our b of x equals sine of x here. So this would give us a period of 360, but we need to change it so that the period is 40. And to do that here, well, to do that here, start with this. Well, sine of x will give me a period of 360. Now, if I have if sine of x gives me a period of 360, well, if I have sine 3x, I'm going to have 1, 2, 3 periods within that. Well, I'm just going to get 360 divided by 3. Okay. Well, if looking at this here, sine 3 of x, the period would be 360 divided by 3. Okay. That's why we've got this. Yeah. If this bit here is 3, and then you do this, that will give you the period for this thing here. But now I want to find I want to find out what A is in order to give me a period of 40. Well, if you look at here, you would get 360. You would get 360 divided by 3. That will give you this thing here, the 120 here. You see, 120 and this 3 here matches up with this. Now, suppose now is A. Well, you would get 360 divided by A, and that would then give you 40. So it's a matter of finding out what A is. Well, when it comes to changing the period, I can never remember. So you might have to use the same logic here. Start with this, and then slowly use a bit of logic to get to A. In this case, A would be, well, it would be you solving this thing here. Well, times both sides by A. Okay, so you would start with this here. Hang on, start with this. Well, when you look at this here, what you're actually doing is starting with 360 divided by 3. That will give you this. So basically, when this is 3 here, it will give you 120, and then you would use the same argument here for the A. Well, I'm trying to figure out A here. That would give me 40. So you would get 360 divided by A equals 40. Well, here it's just a matter of working out A. So times both sides by A, and then divide both sides by 40. So that will give you this. So A is this. So when you put A into this thing here, when you put when you put this thing here into here, it will give you a period of 40. So it will give you this graph here. But remember, the amplitude is still 1. It's still 1. But the good thing is, instead of having a period of 360, we've got a period of 40. So that's the first step done. The next step is to change the amplitude, because we said that the body temperature of the animal deviates by 7 degrees. So if it changes by 7 7 degrees either way. So our first step is to change the amplitude. So at the moment we've got the period to be correct. Now we need to change it. So yeah, to change the amplitude to 7, then here stick a 7 in here. So now this here gives us this function here, this graph here, sorry. And now our next step, hang on, let me move this. Hang on, let me move this across, but bear with me. So here, bear with me. Let me move it across here like this. Okay, so currently, hang on. Currently we are here at the moment. Currently we are here at the moment, and it's giving us this graph here. Our next step is to move everything up. So earlier we were here, okay, with an amplitude of 7. An amplitude of 7. Now we need to move this up here so it hovers around the 100°C mark. So our next step would be to add 100. Okay, so it was, hang on. So it was basically everything earlier, which was this, but then we just now need to add 100. So we translate it up by 100. Okay, so that would give us this graph here. And then our next step is, well, currently our graph is like this. Okay, the lowest point is here, but then we need to sync it with the rising of the sun. We said the rising of the sun was 3 o'clock in the morning. So hang on. So this is our graph at the moment. The lowest point is here. We need to, well, hang on. The period is, well, hang on. We are here at the moment. We want to move. We want to sync this point here. Move it across here so it syncs up at 3 in the morning when the sun rises. But then to do that, let's look at this graph here. Normally it was like this, period of 40. Well, if this is one period here, then this messy diagram here would be 20, would be halfway here. Okay, it's a really badly drawn diagram. So one period is 40. That means halfway would be 20. Now this bit here must be 10 because it's halfway. I know the diagram's badly drawn because if you look at this here, this is really long and this is really short. But going on the diagram, that this point here, this distance here is 10. That means this distance here is also 10. Okay, because the whole period is 40 here, so that means that this distance here is 10. Well, if this distance here is 10, then to move it across so it syncs up at 3 in the morning, we need to move it across by 10 and then move. So we are here. If we move it across to, if we shift it across by 10, it would take us to here. But then we need to shift it across by another 3 to sync it up with 3 in the morning. So basically, overall, we need to add 13. Okay. Well, that's why. Well, here to move this from here to here by 13, you would put this into here. Hang on, minus 13. This here exists in a bubble here. You need to put it into this whole thing here. Okay. So really everything. Hang on, everything's the same. Where is it? So here, let me just move this across here. So everything here is the same, but then you would put x minus 13 into this bit here, into this bit here. So this bubble here is this here. So overall, our final equation for our model is hang on. Oops, it's given by this here. Okay, so this is your final answer here. Okay.